we are going to talk about exploring SQL Mesh today. But before I do that, because it's local data meetup, I always like to kick off with a quick introduction. So, who am I? My name is Alice. I've now been in Nashville since 2013, which makes me relatively old school, but still not native. I was born and raised in London, which is why I have a strange accent, which my friends tell me is mid-Atlantic. So who knows? My background is in traditional science and engineering. So I moved out here in 2013 to do my PhD in materials science. I was then a research assistant professor at Vanderbilt for a while, and I made the big leap into data in June of 2021. So 3 years in data, and first as a data scientist, then to data engineering. And I now work at a company called Whatnot, which is an e-commerce company. They do live stream shopping. If you want to reach out, we can talk about it relentlessly. But for today, we're not going to focus on Whatnot. Outside of work, which is rare, I spend most of my time looking after my tiny dog, Sushi. And I also enjoy 3D printing and pizza and beer, which is very relevant for tonight for those of you in the room. Love pizza. But we are not here to talk about me. We are here to talk about SQL Mesh. And SQL Mesh, per my title, is a data transformation framework. So starting from the very beginning, we need to know what data transformation is. And I should probably move this around so people can see my screen better. Minimize it. Minimize it. Okay, there we go. There we go. So what is data transformation? Well, essentially all we're doing is we're taking data and we're transforming it from one format or structure into some other format or structure. So I asked DALL-E to draw me a picture of that, and it came up with this beautiful pile of boxes turning into an ordered pile of boxes. And I think, honestly, that's not wholly inaccurate. We take our mess and we turn it into something that makes sense, we hope. It can really involve anything. You can change the type of data, you can mod the values, you can aggregate the data, basically into anything that's useful. And we hope that we improve the quality and the reliability of the data. We can identify errors, we can correct things, and we can highlight inconsistencies within that transformation framework. So that brings us to SQL Mesh. What on earth is SQL Mesh? Well, SQL Mesh is an open source tool. It's really a Python package. It's Python based, and it enables data teams to run and deploy data transformations written in SQL or Python. So you can see this is just the diagram of their homepage. I do not work for SQL Mesh. I don't even use SQL Mesh, but I think it's an interesting topic. So I stole their diagram, and essentially what it's saying is SQL Mesh allows you to take any query engine you want within reason for now, because it's a relatively new company, but you can use your Snowflakes, your BigQueries, etc. And you can apply SQL Mesh to your data transformation, so your SQL code or your Python code, and you can use it to add in unit tests. You can do the transformation itself, you can run audits, and you can deploy new things in a blue-green fashion, hopefully to allow you to support your analytics, your AI ML, and any data that you want to shove back into your application or use for other nefarious deeds. The other thing that I find slightly interesting about SQL Mesh is that right on the front page of its website, it says it is more than just a DBT alternative. So by show of hands or thumbs up on Zoom, how many of you have heard of DBT? Cool, cool. About a third of the room. For those of you, this talk's going to be quite interesting. For the rest of you, please ask questions if I've skipped over some stuff, because I'm quite familiar with DBT and I want to make sure that we stay on the same page. But for those of you who have never met DBT before, you will see this is the diagram from their homepage, and it is somewhat similar to the diagram on SQL Mesh's homepage, except they don't give you the details. They just put their logo over the top. And DBT sells itself as the T in ELT, which is extract, load, transform. DBT is also a transformation framework that is written in Python. The difference from a 20,000 foot view is that DBT was founded in 2016 and SQL Mesh was founded in 2022. So one is much more recent than the other. One has the opportunity to learn from the other, and we're going to do some exploration of that today. So why? Well, before I talk about why, I'm going to talk about why you should care. So why should you use a data transformation framework? I'm not particularly passionate either way, whichever one you want to use, whatever floats your boat, but I do think most companies benefit from using a data transformation framework. The reason for this is that it allows you to version control your SQL code. At a couple of companies I've worked at, SQL has been kind of saved on local machines and in files, and like people are running it whenever they feel like it, and it's pretty chaotic. And people say, why does this table look different than it did in 2023? And you're like, I don't know. If you have version control, you can go and look at what the table looked like in 2023, see who changed what, and figure out what the difference was. And you can also use environment management with data frameworks. So I can develop the new table in a development environment before I deploy it to production and change everyone's dashboards. It turns out if you change everyone's dashboards while you're testing something, people get slightly upset. So testing, validation, environment management. You can also add documentation to your code. And in this case, code is our SQL models. And this means that when I've added these two columns together, and the names of the columns, it makes me slightly confused why they were added together, I can add a comment that says why in our documentation, and we can keep that with the table in SQL, and we can go back and look at it anytime we want. Finally, collaboration. If I want to work on the same SQL model at the same time with another human, I totally can. I wouldn't recommend it. It's a bit of a mess, but hypothetically, you could push up to the same Git branch and then, you know, resolve all your merge conflicts. But hey, if you want to collaborate side by side in Git, you absolutely can in this world. Why SQL Mesh? Why am I talking about this today? Well, the real reason is selfish, and I'm kind of okay with sharing that, but I work with a very big DBT project at my company. It's Snowflake backed. We have about 2,500 DBT models, and I manage it with two other colleagues. It supports analytics workflows, it supports ML workflows. We have data fed back into the app from it, and it's self-service. With this model, we've run into abundant challenges. Amongst those, efficiency of our deployment. So when we're going from development and pushing it out into production, it's slow. We have people struggle with the concept of incrementality. Go into that later if you don't know what it is, but people do struggle with it. DBT doesn't natively support column level lineage, and we've had some issues with migrations around that. And then finally, data contracts, which is a big bucket in and of itself, and I won't really get into that today. But making sure that engineers are providing data in a format where it's actually usable and traceable and isn't nonsensical for an analyst on the other side. Similarly, for us passing it back into the application, we have to provide it in a form and in a location where the engineers can pick it up and shove it into the app without doing black magic in order to do so. If you are super interested in that side of my life, I wrote an engineering blog about it. The slides will be shared afterwards. You can go have a look. But this is why I want to look at SQL Mesh. If it's the DBT alternative, what is it? How does it work? And is it better? Why should everyone care about SQL Mesh? Well, if you want to organize, maintain, and change data, and you want to understand a complex set of data transformations, it might be handy for you. So I'm hoping today covers our DBT people and it covers our non-DBT people as well. Anyway, let's get into it. Again, if you are not familiar with DBT and I'm saying something that makes no sense, please stop me and ask for an explanation, because sometimes, like, I'm so in the weeds that it's hard to see that I'm in a field, if that makes sense. Okay, so How do we use SQL Mesh? There is a 5-minute YouTube video that allows you to set it up. If you have Python installed and you're familiar with creating a virtual environment, it's going to take you 5 minutes. If you are not, you're going to have to figure that out first, and it'll probably take you a little bit longer. But I promise that's not too complicated, and there are documents that exist that will set you up. But really, it just comes down to a pip install SQL Mesh. Where it differs from DBT is that you can actually use it in 3 ways almost immediately. So you can use it on the command line, as you would with DBT. You can also use it inside a Jupyter Notebook, and they'll give you a getting started there. But it also provides a UI, a graphical user interface out of the box, which is kind of cool. So I'm going to show you guys real quick, once you get spun up, what that would look like. So I think I'm able to do, here's one I made earlier. Let's have a look. There it is. So I ran the instructions on the 5-minute video. I ran the command in my command line, SQL Mesh UI, and this guy popped up. For those of you familiar with DBT, it looks a little bit like DBT Cloud, but it's free, which DBT Cloud is not. What you will see down the left-hand side is the file system of the advantage of the example project. The meat of a DBT project and of a SQL Mesh project is this models section. Am I big enough for everyone on this screen? Or do I need to start zooming in? We're big enough? Zoom people? We happy? Okay. Thumbs up. Okay. Thumbs down?
No thumbs down.
Okay. I was like, oh no, zooming. Not my strength. Okay. Model. Model is where you keep your SQL code. Anyone who's written SQL before should recognize something along the lines of this. What they add in SQL Mesh is just a configuration block up at the top of the model. We'll get into that in a minute. But other things to note up here, we have our audits. Audits in DBT are tests, but for the RIM, an audit is basically a data quality check. So if I say count distinct ID, I expect that to always be greater than 1. I should not have a negative count of IDs. I can make that assertion as an audit. It will run in parallel with my model, and if it fails, I'll get an alert about it. Okay, so then we have macros. Macros enable you to write. So SQL is a declarative language, which means that you can state things, but you can't do like a for loop or an if. Macros allow you to do that in SQL. You can write your own in here. Tests. So DBT tests are SQL Mesh audits. Ignore me if you don't know what DBT is. But for those of you who are DBT, tests in SQL Mesh are like PyTests, or I can't remember what they've called them in DBT, but they just released them. But basically, you put them in your CI and you put data into it and it spits it out. And if it's not what you expect it to look like, it will fail and you will not be allowed to merge into the production branch of your environment. So tests are more like CI, audits, data quality checks. Okay, then we have this mysterious seeds folder. That's basically where you can keep CSVs if you want to load them into your database. So some raw data in there. Then you have your config. We're not going to get into connections. No one has time and everyone's different. But we will go back and we'll take a closer look at the model now. And Glenn, could you remind me how long do I have?
Well, we need to be out of here by 7.
Okay. Whoa. Hopefully not that long.
Usually, so at least 35 more minutes.
Got it. Okay. Models. Queries and metadata that create tables and views. Everyone happy with that? Everyone know what a table and a view is? Fabulous. Okay. Models in SQL Mesh can include descriptive information as comments. So you'll note down here, I have revenue from orders made by this customer. What SQL Mesh does with that inline comment is it takes it and it shoves it into your database as a comment on the column. So it's slightly different from DBT, which requires you to put it in a docs YAML. SQL Mesh will do it inline. You can turn off that functionality if you choose to, but I think it's pretty sweet, so it's kind of nice. The last non-comment statement is your select query, and that contains the logic of transformation. I'm not going to talk much at all about SQL today, like the select queries, with the assumption that most of you are familiar with them and the documentation is exceptional. We're going to focus on the model thing at the top, the config section, and then what's going on under the hood in SQL Mesh. Any questions about models? Fabulous. Let's keep going. Okay, let's zoom in on that model DDL up at the top. So what can we do in there? Well, SQL Mesh, again, for the DBT folks in the room, doesn't have the concept of the like schema YAML or the docs YAML. Everything gets shoved into the model DDL up at the top, for better or worse. So you name your model up there, and you'll notice that we've got a schema table. We don't carry the database. We also do not use the ref function for my DBT people in the room. We just have schema database. That will become interesting later, but not now. Just know schema table name. We have the kind. The kind would be view, table, or we can use incremental models, which means they're built bit by bit. They're still a table under the hood, but you build them in chunks. In SQL Mesh, you have the concept of the chunk with which you can build. So you can do them by time range, which is what you might expect, but you can also do them by the unique key, so by ID, or by partition. We'll talk a little bit more about that in a minute, but basically 3 different ways to chunk up your data. Embedded kind is like an ephemeral model, which means it doesn't actually exist in your database, but you can write code just to kind of DIY, so don't repeat yourself, make things easier to read. And then you can have kind as seed, which means it's a CSV, and you're chucking it into the table. Okay, so we have a kind. We then have these audits. Those are our data quality tests. Out of the box, unsurprising things, not null, unique combination of columns. And then you can do this for all thing, which says, like, you can make an assertion essentially and say quantity must be greater than 0, or potatoes must be greater than melons. I don't know, whatever you want, whatever you feel like. For all kind of covers your bases. You can also write these as custom should you choose to. We'll talk a little bit more about that later. I would say the next part is where we start differing from DBT. So DBT has the concept of owner, as does SQL Mesh, but in this case, owner is used for notification purposes. So you carry your owner, and if you choose to, you can configure it so it either sends an email or a Slack to that owner in the back end if something were to go awry. Kind of a nice feature, because if you're the person who gets pinged for every model in DBT, you might realize how frustrating that is and want to set up a better way to do that. Then you have this concept of cron. Engineers in the room will know what cron is. DBT does not think about orchestration much at all. SQL Mesh has this kind of built in. So you can say, this model should run daily. This model should run hourly. It doesn't magically do it, and we'll talk about that in a second. I wish it did. But what it will do is automatically partition your data into those chunks so that when you try and operate on a table, it will operate in a daily or hourly fashion, depending on what you've chosen. So if I run the run command 18 times a day, only hourly models will be built in every run. Daily models will be built once in those 18 runs, because it acknowledges that it's already built the daily partition for that day. Does that make sense? Okay. So then you are also required in SQL Mesh to define a grain, a primary key. Data engineers everywhere leap for joy because we have a primary key for every table. I'm sure users would get grumpy, but I'm kind of hyped about it. You can also then use the references to define your foreign keys. That's optional. Then there are other fancy features that I didn't put in the example because I already have too much information on my slides. But you can, if you choose not to do inline descriptions or comments, you can shove them in here as well in your model DDL. And then you have this physical properties thing where you can map specific to your SQL engine under the hood. So if you're a Snowflake, you might want to put in, cluster by this and do that with, some magical Cortex analyst. I don't know, whatever you feel like in Snowflake. But they've made it pretty flexible. They offer a set of key value mappings that they'll pass into your engine for you. Okay. So what about this incrementality business? Well, SQL Mesh's approach is slightly different from DBT. DBT's historic approach, and I do think that's changing, is that incrementality is an advanced feature, and you shouldn't use it unless you know what you're doing. SQL Mesh is trying to make it slightly more like you should use this out of the box if the table fits the need. I can see both going poorly. I have seen both going poorly, but for the sake of SQL Mesh, we can have a look at what they've chosen to do. So they've kind of bucketed incrementality into 3 types. You can either incrementalize something by a timestamp, kind of similar to a partition if you want it to be. And you basically say, this is the time column, and then you add a where clause to your model with that time column involved. In the example there, it's a between. I don't think it has to be a between. You can use a greater than and less than if you choose to, which lots of people prefer because the between is ambiguous. But you can use those to fit your needs as long as you're using the @ symbol on the column that you've defined in the incremental by time range. Incremental by unique key is going to basically hunt for changes to that unique key in upstream tables and reprocess those columns. So in this case, we'd look for any names that have changed in the upstream table, and then we would insert those in. You either kind of have to turn on a changes functionality in the underlying table, or you have to write some pretty funky where clauses. But I think the concept is trying to bring simplicity to incrementalizing on a unique ID, which is quite a common pattern in a lot of tables. So enthusiastic about this, even though I'm not sure it would work out of the box as easily as someone being like, make this model incremental, and I would just do it. So, but it's there. And then lastly, they incremental by partition, which basically processes chunks of data at a time. The 2 examples they give is like, if you only want to process a certain region, I can't think of many applications where I'd want to do that, but you can. I guess changes if things are coming in different time zones might be, you run it 3 times a day when midnight hits in the UK and midnight hits in the US and midnight hits in, I don't know, somewhere in the Pacific Ocean. Then you can also partition on a date, which is very similar to incremental by time range, but different in that you give it a like truncated event date and you reprocess that. So maybe if you're doing orders by day, good fit for a partition. I'm not going to get into it today, but they do also support SED type 2 model types out of the box. Again, I think there's a certain amount of custom SQL that's got to go on in there. I can share the documentation links with you, but they do have a nice kind of official, this is an SED type 2 model. They do also have snapshots, but that's slightly different. Okay. I'm sure there are a lot of questions about incrementality, any that we should cover right now in the flow of the talk. Yes.
What does SED stand for?
Slowly changing dimension. So a valid from and a valid to, essentially. So for example, at my company, people constantly change their usernames. And we want to know what their username was at a point in time. We have a table that has their username, valid from, valid to, and the ID associated with that user. Okay, back to our tests and our audits, just to make sure that everyone knows the diff. A test is going to verify that the output of a model matches expectations. I would expect it to execute either in a CI/CD job or when you're developing every time you create a plan, which we'll come to in a second, but every time you basically diff the old and the new. Okay, tests. Audits are used to validate the data output of a model every run. These are assertions that you want to make in your data that should halt the build if they are broken. So for example, if my username is null, that is probably not good. So I would say username cannot be null, and it will stop all of my downstream models from building that are trying to look at that user ID per point in time. Both are customizable, and audits go in line with your model. Tests go elsewhere. So let's take a closer look. I did some black magic here, so I'm sorry just to put this on the page. This is moving to the top right. That's the same. This is the interesting stuff. So audits, we're making assertions. They're in the audits folder. They can be generic, they can be specific. If you use the at this model functionality, wherever you stick it in the DDL at the top, that's where the model is going to run on. Tests over on the left there, you're going to give it inputs and outputs. It will do whatever transformation you say. And if the output does not match the expected output, then it will be very upset. So very much Python, traditional Python testing, and that software engineers in the room should be intimately familiar with. Yes?
I guess audits, any of them are generated automatically from some of the options in the model. Like if you designate a primary key, would it automatically run like a primary key test in Nanoscale? Or is that only for like metadata, data lineage?
So it will. So the question was for Zoomers, like what are the built-in tests, if you will, and are they applied automatically? Is that a good summary? Yeah. Okay. So if we go back to our model DDL, the built-ins are these guys. Don't click, Alice. Don't. Sorry. Are these guys right here? So are not null and are unique. There's unique by itself, not unique combination of columns. You have to assert those. They will not be performed automatically on your primary key. I think, I didn't build it, but I think that they do that because in some cases, you might not want the whole build to fail based on a bad primary key and like a unimportant table. But yes, there's a good amount out of the box, but you can also write your own custom assertions should you choose to, much like DBT. DBT is in the room. Any other test audit questions? Fabulous. Okay, let's get under the hood. So one of the big selling points back in the day of DBT was the concept of like carrying a development environment and their magical ref function. What a ref function does is it basically templates in a different database or schema depending on the environment you're working in. So if I am in my local environment, I'm going to be working in a DBTA Leach schema. But if I push it up to my production environment, it will then write in the big DBT schema that all of my dashboards and stuff are written of. So 2 schemas, all of the DBT tables in both schemas. There are ways where you don't have to build both every day. You can clone things in if you use Snowflake, for those of you who are interested. But the selling point that SQL Mesh is using to differentiate themselves from DBT is that they do not do this, okay? So we do not have full copies of our production environment and our development environments, and we don't do a different development environment for every user. What they do instead is they have a SQL Mesh schema or database, I think if you choose, which actually carries the tables. Your environment is a view on top of those tables. So my production environment is just a view with a select star from SQL Mesh table. If I then go into my development environment, which is also a view of every table in SQL Mesh schema. And I decide I want to change. So I think actually it's Emily in my example here. So Emily's decided that she wants to change the fact orders table. What SQL Mesh will do is build an additional copy of that table with a v2 flag underneath it in the SQL Mesh schema. And dev Emily will point to the new table. Production will continue to point to the original table. Then, once Emily's done a business and she's passed all her tests and she's ready to go, to deploy the new model, it's simply going to repoint the production view to Emily's development v2 model. And we're all going to move on with those. Okay. So there are two pros there. One is we're not creating duplicate copies of both sets of data, cheaper on storage. We say storage is cheap. We don't care. The other advantage is when we get to deployment time, we simply have to repoint the view instead of having to rebuild the whole model. Disadvantage is there's probably some synchronization stuff that we probably need to think about if we're not just making full tables, particularly if we've got this incremental magic going on under the hood. But this is the kind of big differentiating factor between DBT and SQL Mesh when it comes to development. So one has just two full sets of data. The other one, you have variants, which is what they call the different tables, and views over the top for your different development environments. Does that make sense to everyone? Yeah, Ed.
So like, would version 2 have everything from version 1 plus the changes, or do you have to have lineage to show like version 1 was the truth for this period of time, and version 2 was the truth for this period of time?
You can choose. I'm so glad you asked because it's coming up in my slides. Someone else had a question over here. Can I'll come right back, Ed, but yeah. So anyone? No? Okay. Yeah, so the way that SQL Mesh chooses to handle this, and I'll talk about plans and it will be the next slide following, but it's called changes. Okay, so just so you understand what I mean when I'm saying plan, anyone here use Terraform? Not a fan. You won't like SQL Mesh then. You won't like SQL Mesh then.
Necessary evil, from what I'm seeing, SQL Mesh looks similar to some other things I've used, so I like the idea so far. Yeah.
So Terraform is actually, I also believe, one of the inspirations for DBT. But they basically handle this plan very similarly to SQL Mesh. So if you use Terraform, you know what a Terraform plan is. The SQL Mesh plan is basically the same thing. It's saying, okay, when I deploy this to production, these are all the things I'm going to change. These are the downstream models that will be impacted. And then it has this concept of backfilling. So shall I backfill the tables, which will bring us to our changes? And then if you keep saying yes, eventually it will do the big old switcheroo and point your prod to your development variant. Okay. So in order for a model change to take effect, you have to create a plan and it has to be applied. At this point, you can also insert your CI checks if you so choose, and you can create many other ways for it to fail. But this will ultimately be your blue-green deployment, is a plan and apply. Okay. So what is this magical backfilling that they are talking about? So you get your own physical table. The environment contains a reference to those tables. Garbage, which is in this case, the things you aren't using anymore. So either dead development or the old variants that are no longer in production. They get collected and removed by a janitor process that runs every time you run your submodels. When we say backfilling, it's any update that happens to the SQL Mesh tables under the hood. So that's a view model being created, any time a full model is built, or if an incremental model is built for the first time or has data appended to it. Okay, so backfilling, maybe a misnomer for those of us who do historic data, but essentially backfilling in this case is messing with the SQL Mesh schema rather than just messing with your views over the top. Okay, so this is our change categories. So every time you run a plan, it will collect every model, and that is a kind of within the lineage of the model that you've touched, and it will tell you if it's a direct or an indirect change. Okay, so a direct change is anything where I've touched the table and I made a modification to it. An indirect change is something downstream that I have, by nature of me changing this table, modified in that table. So if I have a select star downstream and I've added a column up here, I've indirectly changed that select star. Okay, then we have directly and indirectly. We have change types, breaking and non-breaking. So non-breaking is something where we can kind of move on from it without anything truly weird happening. So the example that they give is adding a column. If I take a table and I add a column to it, all I have to do is add that column, and it's very unlikely that my downstream dependencies will be affected. A breaking change is something that could have a larger impact downstream. In this case, they've talked removing a column. And in this case, we're going to take a look at every table downstream and analyze the impact of that. The last category that they have here, which is what Ed was asking about, I believe, is forward only. If you assign forward only to your model, any change that is made to that table will only apply moving forward, and it will clone the existing table into the new model and then start adding to the bottom of it. Obviously, if it's full table, I'm going to wipe the whole thing away anyway. But for incremental tables, forward only means it will only go from production onwards. Does that make sense? Did that answer your question? Okay, fabulous. Right.
There's no concept like SQL is completely different, right? But there's no analogous concept because PBT is going to have that physical copy for each schema the way it's built versus this is everything's in that one schema and then you're just building.
Yeah, I mean, there's some overlap with your choice of like how you handle incrementality in terms of like you can like add or remove the columns. You can say don't remove columns that aren't defined anymore, just append them, sorry, just add them. Or you can say match the existing schema, like that part of the configuration for incrementality. But other than that, no, there's not really an analogous concept because to your point, if a model is indirectly changed in this case, it just won't touch it ever. Like there will be no rebuild, there will be no transfer. It just keeps being the same table it always has been. Okay, so how do you actually run this thing? Because you might not develop constantly. So you do need to keep this thing moving. If you have an incremental table, you need to run it every day. Well, we talked about the cron earlier. So you can give your model the concept of time, but it will not magically run itself for you. So you can, there is a built-in scheduler that you could use. You could run this periodically, and like your GitHub CI process, CD process, you can run the SQL Mesh run command. It's probably not going to cut it for most production causes, but SQL Mesh is built to integrate with Airflow. So there's a SQL Mesh Airflow package, and if you open it up, you immediately get your DAGs in your Airflow page. Does anyone not know what Airflow is? You do know? You don't know what Airflow is?
No, I think.
Okay, cool. I have defined it at the bottom just in case. But yeah, it's a scheduling tool. And by default, if you install the Airflow package, when you open up your Airflow DAG, you're going to see the SQL Mesh Janitor DAG, which will run however frequently you schedule it to. And then you'll see these plans down at the bottom. So these are single-use jobs that appear when you run your plan from your development environment into your production environment. You'll also see some incremental stuff down there. That's if you've got an hourly job that you want to run as well as your daily job. It will figure it out based on the config that you put in your model DDL section, and then the Airflow config itself. So not perfect, not sentient and running itself, but does have a tighter integration with an existing open source orchestration tool than DBT has ever. So yes.
It's handling the DAG. Airflow is just the job creation definition.
Yeah, exactly. It just calls like the jobs your DAGs. So I think hypothetically you could split up your project into multiple DAGs, which they call projects in this case, and then you can run them in parallel or different cadences or whatever the hell you want. Okay, but what happens when it goes horribly wrong? Which it probably might at some point. So you've got your DAG, it's running very happily in Airflow. How does it tell you when it fails? Well, SQL Mesh will send notifications either to, well, you can obviously log it in Airflow, but you can also send directly to Slack, or you can send via email using the notification targets and the owner property on your models. These will obviously log things when you start an apply and when you finish an apply, and if an apply were to fail. It will also log a run start, a run end, and a run failure. It will do that to your global notification settings. And then if you have an audit failure, it will do that to the owner of the model. What I did not see in the documentation, and I am not an expert, is like model failure notifications. So if a run fails because of a specific model, I don't think you send that notification to the model's owner. You just get your run failure and you have to go look and then sit back. I'm sure that's in the works because it's an obvious choice, but in their docs, doesn't seem to exist yet. What does exist, which is a feature that I don't think DBT's rolled out yet, although it might have it, I know it's in the works, is out of the box column level lineage. So by default, when you pop open your UI, your DBT Cloud-like UI, SQL Mesh UI, you can see all the tables in your DAG and how they are related to each other. So we've got seed, which is our source data here. We've got an incremental model and it spits out the full model. If I then try and look at a specific column, I can also see how each column passes through the DAG and into what model where. Sounds a bit stupid. I've been in a number of situations where this would have been remarkably handy, one of which is this error thing, because if a model errors, you can be like, oh, what column is that? This is going to be wrong in these downstream models, possibly, or delayed. Yes.
I don't know if Core has it, but
Cloud has it?
Cloud has it. Pretty easy to say. I'm sorry.
Okay. Handy, handy. For Zuma's Cloud, DBT Cloud now has column level lineage, which is nice. Okay, we'll talk about macros. I'm running just about on time. So as I said earlier, SQL is a declarative language. You can make it dynamic, so you can add your for loops and your ifs with macros. SQL Mesh supports macro variables, and then it supports 2 macro systems. So let's talk a little bit about what that means. Well, SQL Mesh has its own set of macros, which have the @ symbol before them. So up at the top here, I've got @execution ds. That would be an example of one of my macro variables. We also saw them earlier with @start ts and @end ts. But we also have functionality here. So you can @def, and you can define a function in line with your code. And then down here, we can't read it. Where's my talking head? We have the @each which is how I get my for loops. So for each item in this list, write me this SQL. And there's also an if. I didn't put an example on here, but they all exist. There's a bunch of supported macros. You can write your own. It's all Python based, and it's designed to fit in line with your SQL. So if I want to define the function, you'll see 2 SQL statements here, which you probably wouldn't see in DBT. This ginger macros thing, I remember, is over here. So the ginger macros is essentially, as I see it, and I see it with a pessimistic eye because that's just me, it's a shoehorn to get DBT into SQL Mesh. So DBT is built on Ginger. It uses this ref function, which you'll see these curly braces floating around all over DBT code. That is Gingerland. And SQL Mesh has set up so that if you want to take your DBT project and dump it into SQL Mesh, you can do it with very, very little change. You really only have to change your refs and your sources, because if you have existing macros, you essentially wrap them in Ginger query begin and Ginger end, and it's just going to do the Ginger templating as DBT would. So I think the idea is that their SQL Mesh macro method is preferred and arguably cleaner, but if you have already built DBT, they're going to make it work for you. Okay. So the other advantage that SQL Mesh had by coming into the game later is that a bunch of query engines support Python and SQL now, whereas when DBT was released, it was really SQL focused, because, I mean, honestly, most of the query engines were SQL focused, but now we have Snowpark and other jazzy things. So they built to support Python and SQL out of the box. It's obviously a Python package. They have wrappers that go around it. They also support a to-SQL functionality where you can write your code in Python, tell it to turn into SQL. It's paired with IBIS, which is another package, but they will turn all of your code into a SQL query. But the thing to take away is that if you have a Python model, it has to return a pandas or a Spark data frame. If you have a SQL model, it should return SQL code, but you can define it in Python if it spits out the SQL code at the bottom. I didn't really get deep into this. It could be a talk in and of itself, but just know out of the box, they support both. You can make everybody happy with your Python and your SQL. The last thing that SQL Mesh built for is scale and multi-project deployment. DBT, for those of you familiar with DBT, now does support multi-project, but for the longest time, you either had to install the project as a package or treat it as a source. They played together, but it was a bit janky. Out of the box, SQL Mesh is ready for multi-project deployment. You do this by simply changing the name of the project associated with your config YAML, and it says anything that is coming into whatever your SQL engine, and I'm going to use Snowflake as an example here because it's what I use, but anything that comes into Snowflake from a SQL Mesh project is going in the same location. If you change your config parameters entirely, you can probably get around that, but by default, it says this is SQL Mesh, and these are the project names associated with it. So I can have 12 GitHub repos. It's going to have one SQL Mesh thing in the bottom. I put an example here, which is their example of multi-project deployment. But essentially, as soon as you add the config YAML to your project, SQL Mesh becomes aware of it. And when you make a plan, you are planning against both projects. So you'll see here, I've modified bronze A, but I have also indirectly modified the silver C and D, which are in a separate project down here. Okay, and then you can backfill across the whole project. So while your code might be split, your database is not, and your plan is not. Okay. Summary, right on time. Transformation as code is great. We should all be using it. If you have more than 2 tables, it's a really good idea. There are options. SQL Mesh is one of them. It seems to have been built with orchestration in mind. What I've taken away from reading the documentation is this was clearly built by data engineers. It's probably more friendly for data engineers than DBT is, but equally, it's probably not as friendly to our analysts as DBT might be if you present it to them through DBT Cloud. Deployment's really fast, and you're going to save storage costs because of the way that the virtual environment comes in. I can imagine you running into challenges by not having those isolated environments, but there is definitely a selling point to using this variant model. It's also definitely been built with DBT challenges in mind. They've put a lot of thought into multi-project deployment. They've natively supported Python and column level lineage. They're being very intentional about open source, and they're being very intentional about providing the SQL Mesh UI for free. That's probably good and bad. One could argue that a company should not focus entirely on its competitor, but you know, I think these are people who've used DBT pretty heavily and are building to deal with the problems that they've met in the past from DBT. It does have very limited metadata with respect to DBT. You're not getting your documentation. You don't have your markdown that you can stick in there and reuse across your platform. And because of the elimination of YAML anywhere outside the config, you're somewhat limited on the way you can comment on things and how you can work with that. And for now, I would argue that it's less flexible than DBT, largely because DBT's had the benefit of 8 years of open source people building things that are useful in DBT. So that's not to say that it won't become more flexible in the future, but at the moment, this is what they've built in 2 years, and this is kind of what you got. If you are interested, I'll share my slides. Here are a bunch of links of things you can read. This is what I read to write the talk, plus a little bit more. And now I will take Ed's question. Yes.
Go back all the way to like where you're talking about what your top, you know, the hard part for whatnot for DBT. Do you feel like SQL Mesh would solve some of those problems?
Mm-hmm. Efficient deployment, certainly. I think the way that the variants work, it's great in some ways. For example, one of the things we really struggle with is bad SQL being written and then trying to run it in the stage environment before we deploy it to production, and it gets stuck in a line, and like we don't have the time or the warehousing to run it in stage. So it ends up getting pushed to production, and then it turns out it fails. With the plan and apply model, it has to have been built in development by the user with a plan. And so if like you don't have to build it in stage to prove that they built it in their own local development environment, if you see what I mean. So that would be great. So efficient deployment, big win. Self-service incrementality, nah, not that yet. It's not the same. There's a layer of abstraction on DBT's incrementality, but you still have to write your own where clauses. And that's where I find people fall down the most. It's like not accounting for late arriving data. And like, hypothetically, it should be easier to run models as partitioned entities for incremental, which takes a lot of this late arriving data stuff away. Like if I run yesterday's data now, I probably have very few late arriving data, and I run it as a partition, and I can re-execute it as a partition. So this is well set up for partitioning, but lots of people want data as soon as possible, and partitions aren't very good for that. So I don't think it's there yet on incrementality. The column level lineage is there. We probably don't use DBT Cloud, and that's the problem. And then as far as data contracts go, I wrote this reading their front page, and they were like, data contracts. I couldn't find anything in the documentation about that. So no, but I also didn't read every page, and so I might have missed something, but it wasn't front and center. Yes, Roger.
Disclaimer, at least for the next 2 days, I'm still on the DBT advisory board. And then I leave it. But for cloud users right now, all of the challenges, well, not necessarily efficient development, but the incremental deployment, the comm level, the data contracts, all that is pretty much pretty changed this past year. There's been tons of changes, and if you pay the money for the cloud, which that's one of the big problems, it can get really expensive. Then it's a great experience.
I will add, so we moved to 1.9 probably like a month ago, and we started using some of the contract style features. Less of an issue now than it was, because you can have public and private models, you can version control your models. I would say it's like, because of the volume of models that we have in our project, we run into issues with versioning and things lasting forever and people not decommissioning stuff. But yeah, I think DBT is ahead on data contracts than where I see SQL Mesh right now.
Plus, pushing into, they're really pushing the envelope in terms of mesh, semantic layer, and all of that kind of this cascading of configurations through multiple levels is something that I love the simplicity here for a small team, but as it gets to really big, not having that cascading effect is scary. Have we been able to, I mean, if I say 2,500 models is what you had before, you probably haven't built that many in data mesh, but how would you?
We don't even use it at the company. This is a purely exploratory topic for a heavy DBT user. I will say we've run into size issues with DBT. I think when it comes to like the lineage, like you stick a 2,500 model project in there and people trying to look at the lineage, it's nonsensical. Like it's absolute insanity. So it basically works right now by selection. So if I have 100 models in there and I pick one of them, all of the other ones disappear. But it doesn't have the nice command-like functionality where I can write in plus and 1+. And I imagine that they will do that in the future. So I think it's behind, but as a selfish DBT user, what I do like about what SQL Mesh has done is it could be wrong, but there's an appearance that because SQL Mesh was released and has added functionality, we've got that functionality in DBT now. So like micro batching, the PyTests, they've appeared in DBT in the last couple of versions very quickly. And so it is nice to have a competitor around as a forcing function for some light catch up on DBT. I would say for the scale of project that we're using, SQL Mesh isn't there yet, but as an engineer, as someone who's struggled with orchestration of a project this size in DBT and being unable to modularize it, unable to, like, by default, pass in hourly, daily, that's going to be a really nice feature in SQL Mesh for people who are running things at different cadences. Because at the moment, we do it all with metadata tags that we've built on our own, and we're using them to select, and it's janky. So that's, I think, what I like about SQL Mesh is it was built by engineers, but that's probably also the biggest limitation of SQL Mesh is that it was built by engineers.
Any questions on Zoom, Sam?
Let me
Any questions on Zoom? Hate hearing myself.
Yes.
Statically generate DDL, like in DBT, actually spits out in that target folder. You can see the you can see select statements, but you can't do it until you actually run it. Can you like audit the DDL?
So the way that SQL Mesh works is it provides the question was, does SQL Mesh provide the raw code, the DDL that it's going to send to your database? And can you see it? The answer is yes. But it provides it in logs. So when I showed the example project at the beginning, what I didn't talk about was the logs folder, and that's going to contain everything. And in the plan step, it will create the DDL, and it will ask you if you want to backfill. That is when it will run, per se, for DBT. So the first part, the plan, is your compile, kind of. It's not exactly the same, but it's similar. And then your backfill is your run. So once you've planned, you can say, no, don't backfill. And you can view the DDL in the logs output folder before you send it to the database.
Essentially, the plan applies is very Terraform-like, but the lack of YAML is not Terraform-like. It's insane that what they want, that didn't take. You know, PBT is very YAML heavy, right? And we're saying this isn't YAML heavy, which would be great for me. So I just found that interesting.
Yeah, so the comment was there's no YAML. And yes, I think it's really elegant when you're looking at it for the first time and you're like, oh, it would be really nice to have this in the DDL up at the top of the model. And you can immediately see a lot about a model from the DDL at the top. And then I'm like, oh, well, if I look at my like YAML associated with this specific model, it's, 200 lines long. And now I'm shoving that into the top of the model if I want to with my column descriptions and blah, 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 blah. And suddenly I have a model that's twice the size. And I'm like, oh, do I want that? Do I not want that? So, good and bad, good and bad. But yeah, I think that there's an argument that could be made either way. And it's good that they've taken the opposite approach because we get to see what struggles come from that rather than the other way around where people don't read the docs YAML because it's not in front of their eyes when they're developing. Any other questions?
Alex, thanks for.
Thanks, Zoom.